dumping Azure storage keys using MicroBurst. Test at your own risk. Authenticate to Azure PowerShell using the following command. When prompted to authenticate, use the Azure contributor user value from the script output as the username and the Azure contributor user password value, also from the script output, as the password. You are now authenticated as the contributor user account. This account assigned the contributor role in the Azure subscription. This account will be used to exploit various weaknesses in the Azure environment. Keep the PowerShell session for this session. Import the MicroBurst module into your PowerShell session with the following commands. The MicroBurst toolkit will import different PowerShell functions depending on which PowerShell modules you have installed on your system. Ignore the warning about the MS Online module not being used. Use the getAsPasswords function to perform a comprehensive dump of Azure storage instances. This function can also be used to extract data plane keys for other PaaS services, but we will exclude those services for now by using the N option for those parameters. When prompted to select an Azure subscription, select your test Azure subscription and click OK. In the resulting output, you should see credentials that were dumped from storage accounts. These credentials can be used to access these services to exfiltrate data or to hunt for other credentials. In the output window, look for the storage account with the name of privstalks. Copy one of the lines using Ctrl+C. Open the PowerShell prompt and install Azure Storage Explorer using the following command. Click on Start button, search for Storage Explorer, and select the Storage Explorer option. In the Connect to Azure Storage window, select Storage Account. In the Select Authentication Method window, select Account Name and Key, then click Next. In the Enter Connection Info window, enter the following information. Click Next. In the Summary window, click Connect. Review the files and note that we now have persistent access to the storage account and the content of all services. This gives a lot of room for an attacker to cause damage. For example, an attacker could encrypt data in the service in a ransomware attack, could encrypt data in the service in a ransomware attack, inject malicious data into NoSQL table stores, or poison applications using the storage queues. While we are not using Lava for this exercise, it is worth noting that Lava has a module called stg_blob_download that will automatically exploit this scenario to download all blob containers in an Azure subscription. Beware that some storage containers can contain significant amounts of data, so there is some risk to running this Lava module. Make sure that you know what you are downloading before initiating download of an entire container. In a pentest engagement, this requires extra care as personally identifiable information may be present in the accounts. Escalating privileges using Cloud Shell account. Test at your own risk. In the PowerShell Administrator console, type the following commands to SSH into the Pentest Linux VM that were created earlier. Replace Linux_fqdn with the value of Linux vmfqdn from the output of the script earlier. When prompted about the authenticity, type yes and press enter. When prompted for the password, enter the value of Linux VM password from the output of the script earlier. In the bash shell of the pent's Linux VM, use the following command to switch to the root user. Use the following command to authenticate to Azure as the contributor user using the Azure CLI. Replace domain_name with your Azure domain name. Also, replace contributor_user_password with the password of the contributor user account. Download and run Lava with the following commands. Verify the current user and permissions using the following command. Scan the file shares in the Azure subscription for potential Cloud Shell images. You can do this using the following Lava command. This command takes advantage of access to the access keys to scan the file shares in an Azure subscription. You can see that we have a file share is used by Azure Cloud Shell. Download the files in the Azure file shares using the following command. We are assuming that you are performing this exercise in an isolated Azure environment that only has a few files shares. Running the preceding command in an environment that has multiple file shares can take a long time to complete. This will download the file into a temporary directory on the pentest Linux VM. Make a note of the download location that is highlighted. After the download had been completed, exit Lava using the exit command. Back in the bash shell, mount the downloaded image file using the following command. Replace download_location with the download path that you made a note of in previous slide. Explore the mounted drive by typing the following command and pressing Tab. You should see an output of persistent files and data from the Cloud Shell user's previous sessions. This includes sensitive information, such as the user, SSL context information. Explore the mounted drive by typing the following command and pressing Tab. You should see an output of persistent files and data from the Cloud Shell user's previous sessions. This includes sensitive information, such as the user, SSL context information. Change the directories to the mounted drive and enter the following command to append a malicious command to the bash file, to escalate the privileges of our current contributor user. Bash is a bash shell script that runs whenever a shell session is started interactively. The preceding command will ensure that the next time the target privileged user opens a Cloud Shell session, the command to escalate the privilege of the contributor user account will be executed. To do the same thing for a PowerShell, we will need to first create two directories in the user's home directory. This is where the PowerShell profile will live. If you get an error message about the existence of the directories, you can ignore that and move on the next step. Similar to what we did for the bash file, we will make the contributor user an owner on the subscription by adding the following command to the PowerShell profile. Unmount the drive from your session with the following command. Now let's upload the drive back to the storage account and overwrite the existing version. First, we will obtain the name of the storage account and store it in a variable. Replace storage_account_name with the name of the storage account that the original Cloud Shell files downloaded from, starts with a prefix of CS. Obtain the access key and file share and upload the image back into Finally, we will need to trigger the attack by opening a Cloud Shell instance as the Azure admin user account. To do this, we will log in as the Azure admin account and open Cloud Shell in the portal. We can see in the following screenshot that our commands were executed in the Cloud Shell instance, and our contributor user account is now an owner on the subscription. Now let's verify that we have indeed escalated our privileges to the owner role. We run the priv_show command in Lava to verify this. You should be able to see that the user is now assigned to the owner role due to a successful privilege escalation attack. So, now that we have verified that the attack was successful, let's remove the owner role assignment from the contributor user so that we can complete the remaining exercise with only the contributor role. In the Cloud Shell, PowerShell environment where you are logged in as the Azure admin user, run the following commands line by line to remove the owner role assignment for the contributor user. This will remove the owner role assignment for the contributor user. Remove the privilege escalation command that was planted by the attacker using the following command. To remove the privilege escalation command for the bash Cloud Shell, run the following command and delete the last line that is highlighted. Save the file using Ctrl+S. Now that we have seen how Cloud Shell can be abused. Exploiting privileged VM resources using Lava. Test at your own risk. Authenticate to Azure using the login Azure CLI command. When prompted, enter the contributor credentials that you obtained from the script output. You are now authenticated with the contributed credentials. Download Lava using the following command. Switch to the Lave directory and run it using the following commands. In the Lava console, confirm the authenticated user using the hoami command. List all the modules in Lava using the following command. Lave has a lot of modules that can be used to exploit resources in different scenarios, but we will using two main modules VM_list_privileged and VM_. Use the VM_list_privileged module to check whether any VM in the subscription is associated with a privileged managed identity. To execute a module in Lava, the command needs to precede by the exec keyword. Here is a screenshot of the command and its output. You can see from the screenshot that the module found a VM, but the VM does not have an associated managed identity. You can also see that the module found another VM that has a privileged managed identity associated with it. The module also displays the role assigned to the VM and the role assignment scope. In total, the module should list two VMs assuming you deleted the VM with privileged role assignments, a Linux VM with the owner role assignment at the subscription scope and a Windows VM with the contributor role assignment. Make a note of the name and resources group of the Linux VM that was found with owner privileges. As we already have a credential with the contributor role assignment, we will focus on exploiting the VM with the owner role assignment to obtain its token for privilege escalation. Use the VM_s module to exploit the run command functionality as a contributor. You will need to specify the VM and resource group as shown here. Here is a screenshot of the command and its output. You should now see a display that looks like shell access to the Linux VM that is the owner role assignment. We can either start running commands as an owner from within this VM, or we can obtain an access token that we can reuse outside the VM. We will go with the latter option in this case. It is worth nothing that this is not an actual shell. In the background, Lava will take the command input, use the run command functionality to execute the command, and return the output. In the shell, run the following command to obtain an access token for the resource manager. This will obtain an access token that can be used to make API calls with the owner privileges. Highlighted and copy the value of the access token, as shown in the following screenshot. Make sure you do not copy the trailing command. Type exit and press enter to return to the Lava console. Type exit again and press enter to return to the bash shell in WSL. Set the obtained token as a variable using the following command. Use the token to run commands against the resource manager with the owner privilege. To install JQ, execute the apt install JQ command. You can try the following commands, but we will only show of the first command. Congratulations! You have successfully performed a privilege escalation from the contributor role to the owner role.
Guessing Azure AD credentials using MSOL Spray. In the Azure portal, click on the Cloud Shell icon in the top right corner. If prompted, select PowerShell. Then, click Create Storage. Then, click Create Storage in the PowerShell session. Within the Cloud Shell pane, run the following command to download a script to provision test users in Azure AD. Verify that the script was successfully downloaded using the following command. You should see a script called create-test-users.ps1. Execute the downloaded script using the following command. When prompted to enter a password, enter my password 123 and press enter. The script will provision 5 new users in your Azure AD tenant with the password that you entered. In the script's output, at the end, make a note of the user principal names and the password. You will need them for the password spray attack. Close the Cloud Shell windows. In the Azure portal, click the Hub menu icon in the top left corner and select Azure Active Directory. In the Azure AD console, in the Manage section, select Users and click on Multi-Factor Authentication. In the Azure AD console, in the Manage section, select Users and click on Multi-Factor Authentication. This opens a new multi-factor authentication settings windows. Select the users Adaze and Juan and click Enable to enable MFA for them. This opens a new multi-factor authentication settings windows. Select the users Adaze and Juan and click Enable to enable MFA for them. When prompted, click on Enable Multi-Factor Auth, and then click on Close. In your VM, open the PowerShell console, switch directories to your user's directory, and clone the MSOL Spray GitHub repository using the following command. Import the MSOL Spray PowerShell modules using the following commands: cd MSOL Spray import module, MSOL Spray.ps1 create a username list using the following command, notyped userlist.txt. When prompted to create a new file, click Yes.
Paste the username output that you made a note of earlier into Notepad. Save and close the Notepad document. Run MSOL Spray against the user accounts using the following commands. Specify the password output that you made a note of earlier. You should see a success message for all the accounts, but you should also see the output for the accounts that you enable MFA for.
Open the Azure Ad Portal in private or incognito windows. Sign in with Sandra's credentials. You should now be able to access the Azure Ad Portal as Sandra. Also, you should be able to review the information of other users in the Azure ad tenant as Sandra. Go back to Azure Cloud Shell, logged in as the Azure admin user, download the cleanup script to remove the test users that were created earlier and validate the download using the following commands. Execute the script using the following command. Now that we understand how to guess credentials for users, let's look at additional situations that may limit our ability to use these credentials in an Azure environment.
Hunting for credentials in the container registry. Test at your own risk.
In your machine, open PowerShell console as an administrator, switch to WSL, and authenticate to Azure using the reader user account. Replace domain with the domain name from the output of this setup script.
List the container registries in the subscription using the following command. You can see there is a container registry with the name format XXX, where XXX is a randomly generated number during deployment. Make a note of this name. Install Docker on WSL using the following command. Generate a Docker login for the registry using the following commands. Replace ACR_name with the actual name that you made a note of in step 2. Also, connect to the registry using the generated token. List the images in the container registry using the following command. You will see a single repository listed called node-app-web. An image may have multiple versions stored in the container registry. We can enumerate the versions using tags. List the tags for a specific image in the container registry using the following command. You will see a single tag called v1. This information is useful as there may be multiple versions of the same image in the repository. It is not unusual for previous versions to contain sensitive credentials, but they have just not been cleaned up in the registry. Make a note of the registry credentials that we will need in subsequent tasks. Run the following commands in the WSL session and make a note of them. Open a new PowerShell console as an administrator. Set the values from step 4 as variables. Replace login_server and access_token with the values from step 4. To pull the image from the registry to your local cache, you will need to use the PowerShell console, not WSL. This is because WSL does not have access to the locally installed Docker application. Newer version of Windows 10, build 18362 or higher, support this, but it is not yet supported for the build version on our lab VM. Connect to the container registry from the PowerShell console. Pull the image from the container registry to your local cache using the following command. If you get an error message when pulling the image, you can troubleshoot by first, in the Docker for desktop Windows, clicking in the troubleshoot icon. Ensure that the Docker status icon displays green. If it is any other color other than green, click on the option to reset to factory default. Examine the downloaded image for sensitive credentials by using the following command to list out the environmental variables. You will see that this image has service principal information embedded in it. We can test this credential to see whether it is still valid and the level of access that it has. Make a note of the app_i.d, app_key, and tenant_i.d values. Switch back to the WSL session that you have open. Authenticate as the service principal using the following command. Replace app_i.d with the app_i.d value from step 10. Replace secret_key with the app_key value from step 10. Replace tenant_i.d with the tenant_i.d value from step 10. Press enter. You are now logged in as the service principal. Next, we will verify the permissions that this service principal has. Verify the role assignment and scope of the service principal using the following command. Replace app_i.d with the app_id value from step 10. You can see that this service principal is assigned the contributor role at the subscription scope. Awesome! We have managed to escalate permissions from the reader role to the contributor role using a credential that we scavenged from an image in the container registry.
Hunting credentials in resource group deployment. Test at your own risk. Open the test file where the enumerated resource group deployment information is stored. The file will be in the MicroBurst output folder. Oz subscription name resources deployments.txt. Our subscription name is development. You will need to change this to your own subscription's name. Review the parameters and output section of the file for exposed credentials. You can search for the terms outputs and parameters to locate the interesting information faster. You should find the host name, username, and password to a Linux VM that is exposed in a past deployment. Copy the SSH command output, as you will need this to connect to the Linux VM using that you found. Also, copy the password value. In the PowerShell session of your Pentest VM, paste the SSH command that you copied in previous slide and press enter. PowerShell now supports SSH natively. Type yes and press enter when prompted about the fingerprint. Enter the password that you copied from previous slide and press enter when prompted. You should now have shell access to the Linux VM using the credentials exposed in the resource group deployment output. From here, we can look for opportunities to move laterally or escalate privileges. In this case, let's check to see whether this Linux VM has a managed identity associated with it. As part of checking for the managed identity, we will be querying an Azure Instance Metadata Service, IMDS. Remember that a managed identity is an identity that can be associated with an Azure resource and granted permissions in Azure. Review the Azure VM Instance metadata to obtain more information about how the VM is configured in Azure. While this is a test system in our environment, you may want to avoid adding additional tools to a system that you have compromised in a test. In this case, JQ helps us to get a well-formatted JSON output. The output will contain information about the VM's compute, network, disk, and other configuration. Check whether the VM had an associated managed identity using the following command. If one is used, an access_token will be returned, and this could present an opportunity to escalate privileges. You can see here that we got an access token for the Azure Management Plane, Resource Manager. This token can now be used to interact with the Azure REST APIs. The MicroBurst toolset had a set of functions that can use these tokens to interact with the APIs to gather key vault secrets and storage accounts keys and even run commands on VMs. While we could use the access token with the Azure REST APIs, it's much easier to use the Azure CLI to interact with the subscription. Since this is our testing environment, and not a client's, let's install the Azure CLI to check the permissions that this VM has. Install the Azure CLI on the Linux system using the following command. Log in with the VM's managed identity using the following command. Let's verify the permissions that this identity had using the following two commands. First, we will make a request for Linux VM resource information and cast it to the append variable. In another environment, the $hostname environment variable can also be referenced instead of the hard-coded VM name used here. Using the append variable, we will list the role assignments for the subscription, specifically querying for the principal name, role name, type, and scope. Awesome! This VM has the contributor role applied as the subscription scope. This means that we now have write access to the subscription. Credentials can appear in many different forms in deployment details. Common sources include parameters, outputs, and HTTP links with active SAS tokens. So, make sure that you keep an eye out for less obvious sources. Stealing and reusing tokens from an authenticated Azure admin system. Test at your own risk. In the PowerShell session within the Cloud Shell pane, run the following commands to download and verify a script to provision the scenario for this session. Run the download script using the following command. When prompted to enter a password, enter my password 123 and press enter. Wait for the deployment to complete. The deployment could take up to 20 minutes to complete. After the script has finished running, the key information that you will need for the rest will be displayed in the output section. Copy this information into Notepad document for later reference. There are 6 values that you will need from the output session. Azure Admin User. This is Azure Administrator username whose token will be stolen from a Windows PC. Azure Admin User Password. This is the password of the Azure Administrator user whose credential will be stolen. Windows VM Public IP. The public IP of the Windows VM that the token will be stolen from. Windows VM Username. The local user that you will use to authenticate to the Windows VM. Windows VM User Password. The password of the local user that you will use to authenticate to the Windows VM. Exfiltration Storage Location. The blob container that you will exfiltrate the stolen credential to and download it from for reuse from your machine. Open an RDP client on your PC and connect to the Windows VM public IP that you made a note of in the output section. When prompted to authenticate, use the Windows VM username value as the username and the Windows VM user password value as the password. Within the RDP session to Windows VM public IP, open a PowerShell console and authenticate to Azure using the following command. When prompted to authenticate, use the Azure admin user value from the script's output as the username and the Azure admin user password value, also from the script's output, as the password. Verify authentication using the following command. At this point, we can pretend that we're acting as the victim admin user and saving our current context for later use. We, as an attacker, would then copy this file to our system. Alternatively, imagine that you're an attacker with an active session on this system and that you want to save the current context for exfiltration to another system. Save the current authentication context and verify that the context has been saved using the following command. Compress the saved authentication context using the following command. Exfiltrate the compressed authentication context to the blob container that was created earlier by the script, using the following copy command. Replace the blob _container _u.tar.l placeholder with the value of exfiltration storage location that you copied from the script's output. Ensure that there are no line breaks before pasting this. You should get an HTTP 201 response. Verify that the compressed authentication context now exists in the storage account by browsing to it in the Azure portal. The storage account has a naming format of pentest. XXXX is a set of random digits that are generated by the deployment script. Open a PowerShell console and verify that you currently do not have a connection to the victim's Azure environment by using the following command. You should get an error message. If you are authenticated, use this Connect Oz account to log out. Download and verify the exfiltrated context file using the following command. Replace the blob_container_u.tar.l placeholder with the value of exfiltration storage location that you copied from the script's output. Extract the downloaded file using the following command and verify the extracted file. Restore the authentication context to your machine using the following command. Verify that the context has successfully been applied to your machine by running commands with the stolen admin authentication context. At this point, you have validated that an authentication context can be stolen from an administrator's system, exported, and reused from an attacker's system. Now that we've completed, go back to Azure Cloud Shell, run the following command to download a cleanup script and verify the download. Run the downloaded script to clean up the resources that were created for this using the following command.